Hello friends! Welcome to Coding Garden with CJ. Welcome to Code Katas number 16. It's gonna be a fun time. Let's say hello to everyone in the chat. Okay, so we've got Alan, hello, who says, I saw you on the coding train and instantly subscribed. Heart. Thanks for tuning in. JT, welcome. Alan, and Ran, and Alka, welcome to the show. And Ran asked, is Dan that tall, CJ? I don't think he's that tall. I'm actually really short. You can't ever tell how tall I am because you just see me here, but I'm a pretty short person. And King David, welcome to the stream. And Human, hello. So if you're not familiar with this show, I do this pretty much every Wednesday where I solve Code Katas live on stream. And I have a GitHub repo. It's at github.com/codinggarden/code-katas. And every episode, I'll upload the code that I write to solve the specific katas. Typically, I have them picked out ahead of time, but I've been very busy, so I haven't done that. And so I'm going to pick them out live in front of you, and we'll solve some. So typically, I will choose various difficulty levels. So they start off as fairly easy at 8Q, moving all the way up to 1Q, which is the most difficult. I'm going to start by picking a 7Q problem and see how it goes. And hello, lots of people from the coding train. Welcome, welcome. Ashfaq and hello, El Borate. Welcome. Yes, it was so awesome to get to see Dan's face and to meet him. And he's just so extremely nice and welcoming. It was awesome. Very, very cool. There were people in the chat yesterday mentioning that my break timer wasn't kicking in. So if you watched my stream before, I actually have a break timer that every 15 minutes it reminds me to pause, take a quick stretch, and for whatever reason it wasn't running yesterday, but I think I got it going today, so that should pop up during the stream. And that's a good point, JT. I also had it on top chat. I switched it back to live chat. Cool. Alan is asking, is your show also sponsored by water? Yes. Delicious water. And actually, this is flavored water, and you know what? I have no shame calling out the company that makes this. Let me see if I can find their website. So I work in a co-working space, and Bevy, the smart water cooler. So this is actually really, really cool. So we have two of these in our building, and there's like a touch screen, and you can choose the flavor of water you want, and you can choose whether or not it has fizz in it. Today I actually got non-fizzy raspberry water. Pear is also one of my favorites, but this thing is super cool. We have two of them in our building, and that is what is in this water bottle right now. Alka says, I've never been a flavored water fan. It gets me to drink water more. It keeps me hydrated all day because I try to drink at least one of these a day. Most times two. Okay, I'm stalling. We need to pick a kata because I haven't picked one yet. I think the ones without a check are ones that I haven't done before. We'll see. It'll say train. Yeah, so if it says train again, I think that means I've done it before. You're a square? Let's see. You like building blocks. You especially like building blocks that are squares. And what you even like more is to arrange them into a square of square building blocks. Given an integral number, determine if it's a square number. Okay, let's figure out what a square number is. In mathematics, a square number or perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. Okay. The test will always use some integral number, so don't worry about that in dynamic type language. If I'm understanding this correctly, a squared number is some number that can be reached by squaring another number. So 0 squared is 0. Cool. 3, there is no combination of things that can be squared to reach 3. 4 is 2 squared, so it's true. 25 is 5. Okay, I think let's do this one. It seems fairly easy, I think. Let's try it. Train. So the idea is we need to find if the given number is a square number. That is there some integer that when raised to the second power is equal to that number. Oh no, is the site not loading? I actually paid for, what is it called? Code Wars Red? My internet's being really slow. Let's see. Lots going on in the chat. Welcome, everyone. It's so fun. So glad to have you here. Yossi, first time viewer. I like the channel already. Appreciate it. Thanks for stopping by. Oh, and King David says, check your mail. You know what? I've just been so busy. But yes, I got your email. I will try to remember to respond pretty soon. Oh, yeah, and Alka made a suggestion. So if you saw my stream on Coding Train, I created this website, which is Twitter for Cats, and Alka gave some CSS suggestions, which basically made it so the Muse are a little differentiated. But yes, I added it, Alka. Thanks for that suggestion. Cool. JT is saying, I'm guessing using square root is cheating. Honestly, I think that's one solution, right? You take the square root of a number, and that gives, if it gives you an integer, then you have an answer. I think that's one solution that we'll use. But what I was going to mention is, I don't know. I paid $5 a month to get. Oh yeah, Code Wars Red. Apparently, it's supposed to run your tests faster. I don't know. I use the site all the time, so I thought I might as well pay for it. Okay, so what I usually do is bring these things down locally, and I'll run it in my code editor here. So what's this one called? This one is called You're a Square. Let's just copy the name. .js, and then we are going to use this function. Cool. I don't like function expressions. I like function declarations, so I'm just going to change this. Work the same way. Cool. And then let's bring down some of the examples here. Cool. Instead of test assert, let's just console.log it. And negative numbers cannot be squared. 0 is a square number. Cool. I'll leave that there. I typically use this thing called Quokka. So Quokka.js will actually run the code inside of my editor, and we'll see any console logs actually printed inside the editor. So this will do that. And so if I fire that up right now, our function just always returns false. So we're just getting false, 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 true, false, false. Basically, we want to get it so that these two, basically the return of the function and the expected value print the same thing. So we need to work on that. So JT mentioned it. We could just use the square root. I guess let's do that initially, but we also could do it with iteration. You could basically like check every number up to the number to see if that number squared equals it. Let's do that first, just because it'll be fun to do some iteration. So we'll say iterate, and probably we only want to iterate up to, I mean, we could iterate up to n, but mathematically there's probably a better number that we could iterate up to. So let's just say iterate up to n. And square the current iteration value, or like index. If the result is equal to n, return true. But if we get all the way up to the n and we don't find anything, then we return false. Cool. This seems like a very silly solution, but let's code it up. So what I mean by iterate up to n is we can have a for loop that goes from 0 up to, and there's my break timer. Rejoice. So this usually pops up every 15 minutes. I'll take a quick stretch. Yeah, and then Christian has a suggestion up to the square root, but I mean, if you're just going to take the square root, then why not just see if the square root is an integer, right? So let's just go, like, it won't hurt to go all the way up to n, but there's probably something better. So square the iteration value. So let's say value squared is math.pow of I and 2. Just a second, I want to see if this kata supports, ooh, okay. So it supports Node version 8.13. So I believe instead of doing math.pow, I can actually do I star 2. So this is new syntax in ES 2017 or 2018 that will raise a number to a power. So this should work on Code Wars. Cool. So square the value. If value squared is equal to n, then we return true. Otherwise, we return false. Did it work? No. Okay, so negative numbers cannot be square numbers. So that's actually working. 0 is a square number. Maybe that's where we're messing up. Yeah, because if we let I equal 0 and we go up to 0, this thing won't iterate. So we kind of need like a special case. If n is equal to 0, return true. Okay. 3 is not a squared number. 4 is a squared number. 25 is a squared number. 26 is not. So our silly little function here is working, but let's make it better. Let's not iterate up to n. Let's find the best number to iterate up to. Ooh, so I have some good suggestions in the chat. Let's take those into account. So I'm gonna leave my first solution, and actually let's plug this into Code Wars and see if it works. But then let's find some other ways to do it. Sample tests seems to work. Cool. So let's get rid of these. Oh, and I'm actually really excited about this exponentiation operator. Like a lot of times the katas have Node version 6 checked, so I can't actually use some of the later features of JavaScript. So that's cool. Okay, well let's catch up on the chat. People are suggesting iterate up to n divided by 2. Is that correct though? Like, does dividing by 2 have anything to do with the square? Let's see, for the cases that we're trying, we'll put n divided by 2. Let's see. And it seems to break for 4, but that's because we should probably do less than or equal to, and that fixes it. Okay, it works for like the most basic cases. Let's see. Sample tests. I want to try this because when you do an attempt, it runs it against a lot of other tests. Let's see if only iterating up to n divided by 2 will still work for their tests. 1 failed. Okay, let's see which one failed. Your answer was wrong for 1. Expected true, instead got false. On which one? Can we log in? If there are any like mathy people in the chat, let me know if this makes sense in terms of like from a mathematics perspective. So n is 1. Your answer is wrong for 1. Expected true. So is 1 squared 1? Oh, it breaks for 1. Let me. I think I could fix this to work for 1. I think if I literally just did if n is equal to 0 or n is equal to 1, that should fix it for the case where it's 1. Cool, that works. But let's catch up on the chat. So iterate up to the square root. I mean, I think that makes technically the most sense, but I think if we're taking the square root, we could go ahead and just see if the square root is a whole number, then we know that it's a squared number. And AJ did mention you can stop the iteration when the result is larger than n. So if value squared is equal to n, return true, else if, oh no, let me do this in, we'll do it right below. Else if value squared is greater than n, just immediately return false. Not doing anything too different, but that might have actually ran a little bit faster. So let's see what happens here. So right now it ran in 713 milliseconds, but if I remove that, Oh, it actually fits faster without it? What? Interesting. I mean, these are random tests, but it appears that if I remove this else if, the code is actually running faster. Oh wait, it's just random. Well, it's not random. It's the fact that it's a different run, potentially on a different container every time. I don't know. Yep, and yeah, everyone caught that. Like, if it's 1, it's going to break because this n divided by 2 would not iterate for 1. Hey, Randy, welcome to the stream. Yeah, you will never need a case for more than n squared. Cool. So that works. I think I'll leave the else if in there. I think it depends on like what computer you're running on. If you tried this a bunch of times over and over again, this should have better performance because the moment you find a number greater than n, you know that you're done. Yeah. So here's what I want to do. I want to say, well, we can do that, but then we'll just say if, well, just return math.square root of n is an integer. I think is it like number.is integer? Yeah. So if math.square root is a whole number, done. There we go. And that should do it. Yeah, awesome. And that runs actually a lot faster. I mean, again, I think it's all relative because it really just depends on where the code is actually running and where the tests are running. Interesting. I'm getting all kinds of cool suggestions. Let me just try. So Una Catfish is saying you could test n raised to 1/2, which would be 1/2, and check to see if it's a fraction. If it's not a fraction, it's a square. That's some interesting math. Let's try to do that. So test. Yeah, but by my is integer here would be the same thing as checking if it's a fraction. So if I just do n raised to the 1/2 power, I don't know if I have to put the 1/2 in parentheses. Maybe. So if n raised to the 1/2 power is an integer, seems to work. And actually, do I need these checks if I do that? Yeah, I guess I don't need these checks if I do that. Cool. Very interesting. I don't have a whiteboard handy, but it would be interesting to see why this is the case. Cool. I think Alka has another one. So if you do, so take the square root and check to see if that number modulo 1 is equal to 0, meaning there's no remainder of the division. So I think that's the same thing as doing number is integer. Oh, there we go. AJ Christian, you're saying raised to the 1/2 power is just another way of doing the square root. Interesting. I'm curious if it is more performant to do it this way rather than actually just calling. I mean, this function under the hood might actually just do this. I don't know. Roots are powers that are fractions. You know what? I have a minor in math, and it's been so long since I've actually done math. Cool. So this is fun. Pretty simple one, but a lot of different ways to do it. I think I do like, this one is like fairly readable, right? So if the square root of the number is an integer, then that means it is a square number. So I'm going to submit this one. Attempt. Cool. Submit final. Yay! Oh, someone actually submitted what Alka did. So square root of the number mod 1 is equal to 0. This basically means if there is no remainder of the division of 1, then it's an integer, meaning it's a number that doesn't have a decimal. Someone arrow functioned it. What the heck does this do? I'm curious. Tilde? What's the tilde operator in JavaScript? Oh, it's a bitwise operator. Ah! Oh no. Inverts the bits of its operand. A bitwise not. Okay. This might be too much for me right now. I did have a very busy day. So you not it. I mean, I don't think it's different than just an exclamation mark. Not in is equal to in. But bitwise shifted. Alka saying bitwise is tons of fun. Maybe I'll sit down and learn it one day, but I think Me has submitted solutions before that like use bitwise operators, and I have no idea what's happening. I just have to learn it. I've never sat down to learn it. Suggestion from L. Barrett. You could have added a condition to speed up by even or odd number checking only half of all iterations. So basically, you're talking about, I guess, oh no, okay, here we go. The situation where I'm using a for loop. If I is, if n is even, then I'm looking for an even number, and if n is odd, I'm looking for an odd number. Is that a rule in mathematics? An even number squared gives you an even number, and an odd number squared gives you an odd number? That sounds right. Yeah. I like it. I don't think I'm going to do it because I already submitted it, but good suggestion. Cool. That was fun. We picked one at random and we actually solved it. Cool. Let me post a link to it in the README. Okay. Now we're going to get a little bit harder. We're going to move on to a 6Q. Yeah, and the suggestion that Elberate mentioned is for very large numbers, basically where you have to do a lot of checking in that iteration. That would make a performance difference because you're not doing as many operations in the for loop, which would be like actually squaring the number. So you would only square it if it was the given either even or odd based on what was passed in. Cool. Okay, 6Qs are a little bit harder, so let's choose wisely. Okay. All the ones with the check, I'm pretty sure I've done before. Done a lot. Playing with digits. Let's see what it's about. It says train again, so I think I've done it. I don't know if I've done it live on stream. We'll hold on to that one because I can search the GitHub repo to see if I've done this one live before. Replace with alphabet position. Let's see what this one is about. Welcome. In this kata, you are required to, given a string, replace every letter with its position in the alphabet. If anything in the text isn't a letter, ignore it and don't return it. A being 1, B being 2. I like this because it's kind of like encoding. Oh, and actually, it reminds me, Alka, at least... these messages are hilarious on the thing that I made, but it says this was from Alka. I don't know if it really was from Alka, but this is an awesome encoded message. Actually, I'm just going to show this really quick. So someone could have been Alka, may not, because anybody could have posted this and said from Alka, but posted this message for me to decode. And basically, let's do it because it's really fun to see what this will decode to. And this problem, the idea of like taking every letter and replacing it with its alphabet number, could be a way of encoding something. You could like do several transformations on it. And Alka's mentioning, look at that, but I have, and I decoded it. I did it very carefully because I didn't know, for one, if it was you. And one very interesting thing someone can do is you can take a string and like shift the characters to get like the word fetch and then eval it to like make a request to a server or something like that. So like I did it like one piece at a time just to make sure that like I wasn't gonna run some like arbitrary code. But it's basically just a set of encodings. Let's check it out. Save this file. Message from alka.js. Okay, so the code, and one thing I did to kind of like make sure that I could read it is on every parenthesis, I did a new line. So you can kind of like see the nesting and where things go. So this is a split and then a map, so I'll return there. And then I have this handy plugin in VS Code that matches my brackets with the color, so I can tell that these two parentheses match up. So a new line there. And then this one matches with that one. This one matches with that one, and that one matches with that one. Okay, so this takes this long line of code that's kind of hard to read and makes it something that's more readable. And then the code he wrote was this.name. Basically, it was a reference to in the the object that represents this thing right here had a name property and a content property. So really, this.name is like this. So it's really this. So split this. I guess that's the word match, but on every two words. So I believe this, if we just run this code right here, it's going to split it to every two characters are in a value in an array. So like if we just logged that, let's start Quokka. Oh, A to B is not defined in Node.js. I might have to do this in the browser. Let's just comment this out for a second. Cool. So this is a regular expression that matches a word of length 2. So my guess is every two letters, not two letters, every two characters in this, which are numbers, and some are letters, get put into an array. So we get this array separated by spaces. Cool. And so after that happens, we then map it. And if it was the empty string, because you saw in there were a bunch of empty strings and it's empty. Otherwise, string.from code point. I had never seen this before. Code point. But yeah, I thought maybe it was from char code, because I've used that before, but code point is different. It returns a string created by using the specified sequence of code points. So like this will give you some like Unicode strings. So these code points actually give you like the snowman, the star, the recycle sign, like a kanji character. So that's cool. So basically we take each of those numbers in the array, parse it to a base 16 number, I think. So let's see what parse int does. This is fun, Alka. Thank you for this challenge. Well, not a challenge, but just like understanding what's happening here. So we do parse int. Yeah, so the second parameter to parse int is the base. So if I pass in 16, it's going to parse it as a base 16 number. And then the result of that is going to be passed into from code point. Let's just run this code, see what happens. I'll have to run it in the browser. Go. And it gives us this coding garden and then like some weird thing there. Okay. So we get that. Oh, and one thing to mention is like this is going to create a base 64 string. So A to B is a function built into the browser that takes in a base 64 string and decodes it, I believe. Yeah, decodes a string of data which has been encoded using base 64 encoding. So this whole thing eventually turns into a base 64 string, and then we decode it, which gives us this, and then we escape that, and that gives us a nice little message. Let's see if this will work. There it is, Coding Garden Heart. Yeah, let's see. Okay, I'm gonna catch up on the chat because I was getting just like trying to walk into all of those different functions. Yeah, so code point supports Unicode. Char code is UTF-16, so like a hexadecimal encoding. Rancid, it looked like a fire emoji. It's something interesting. It's some kind of emoji, but you'll notice there's a bunch of spaces, or not. They're not probably not spaces. They're part of the encoding. And then Alka saying ASCII to binary. Is that the A to B? Was that what that stands for? Yeah. So base 64 ASCII encoding to. Well, I thought it decodes base 64. And yes, it is a purple heart emoji. So thank you, Alka. Heart. Cool. That was a fun detour. But let's do this one, which is replacing all the characters with their alphabet position. So again, I'm going to bring this down locally. Let's create a new file. And we'll bring down the function. And we'll do this. But we'll turn these into console.logs. And then start up Quokka. Actually, can I do this? Might be easier to read. Does anyone know what the narwhal bacons at midnight is from? Is that even still a thing? Because it used to be a thing, and people were like, this shouldn't be a thing, but it was a thing. Okay, so right now, the function is just returning the text that you give it. We need to get those alphabet codes. Hello, gaming, but not really. Welcome. Mentioned that you saw me on Dan's stream. It was a super fun time yesterday. Okay, how are we going to do this? So basically, we need like a place to store the alphabet numbers. So it could be an array, it could be a string. Basically, we need a place where we're going to store all of these things. And then we need to iterate over the text. And then while we're iterating over the text, we're going to get access to each letter and we'll say get the alphabet number for the given letter, add to alphabet numbers. So this thing up here, and then that should be it, and then return it. Now this is very general and generic because we could use an array and then join it. We could use a string and like start appending to it. First thing is and one of the problems we need to solve is getting the alphabet number for a given letter. I'm curious. Let's see. Narwhals or bacon? Yeah, Tio saying it's coming from Reddit. Yeah, so it used to be a thing. Like they said or they would say go into like a public place, and if you say the narwhal bacon's at midnight, people that actually use Reddit will know who you are and you'll make friends. In the real world, nobody would say that or use it. Gaming but not really is asking, so what exactly are you working on? In this show, Code Katas, I go to this website, codewars.com, and pick coding challenges. They're basically like algorithmic problems that involve like iteration, using features of the language, and basically you're solving code problems, similar to problems you might have in a whiteboarding interview or as a code test before getting a job at a place or something like that, at a company as a place. Yes, so the challenge to get the alphabet number for the given letter, I have a suggestion to use the ASCII code. Yeah, so you can get the character code for a given letter, and then using that character code, we could do some maths to make it between 1 and 26. Yeah, and that's what AJ is suggesting. Get the ASCII value and then do some math on it. I think so. One thing we have to be careful for is capital letters, because capital letters have, I believe, higher ASCII values maybe lower. We'll figure that out. They have different ASCII values than lowercase letters. So we would probably want to convert to lowercase and then convert the number. Okay, but let's do it. So for a place to store the numbers, let's just use an array, mainly because I know that I'll be able to like join it at the end with spaces. Maybe we'll see this with the for loop too. I don't know. First off, let's just say numbers starts off as an empty array. Then we need to iterate over the text. For this, I will use a for loop. We could potentially turn this into a map. This whole thing could be a map because we're mapping from one. Well, maybe not, because you'll notice that the letters are separated by spaces. A map typically returns an array of the exact same length, so maybe not. But we need to iterate over the text. Definitely could use a reduce, but we'll just do a for loop. It starts at I, and then we want to go to the length of the text. We're going to get access to the letter, which will just be text at I. And so now we need to get the alphabet number for the given letter. So let's do some checking. So I keep saying so. Maybe I should stop saying so. But letter T dot char code at 0. What is the character code for the letter T? Well, actually, let's start at the beginning of the alphabet. So the character code for A is 65. The character code for lowercase a is 97. So actually, I was wrong. Uppercase letters have actually a lower character code than lowercase letters. But what we could probably do is say, okay, get the character code, and then I want to shift this down by 64 because this minus 64 gives us the number 1, which is what the letter A is. And if we do the same thing with like the letter Z dot char code at 0, that gives us 90, but 90 minus 64 is 26, and that's the 26th letter of the alphabet. Cool. I think that's all we have to do, and to account for lowercase letters, because it's going to break if we do an uppercase letter, a lowercase letter, but we could just say a dot to uppercase, so like always send it to uppercase, and then subtract it. I think that's our winner. This is our maths that we will do in our function. So the number in the alphabet will be letter, send it to uppercase, get its character code, and subtract 64 from it. Then we'll just push the number into numbers. Actually, I think we do need to do one check, though. So we need to make sure that this value is between 1 and 26, because if we look at the description of the problem, if anything in the text isn't a letter, ignore it and don't return it. So like when we come across a space, we wouldn't want to do that. So really, I can just say if number is greater than or equal to 1 and number is less than or equal to 26. So if it's in the alphabet, put it in that array. And then the last thing is we need to return numbers, and we'll join it together on the space. What do we got? So 28, 5, 14, 1, 8. I think we're doing it. Cool. Let's catch up on the chat. Yeah, and so I didn't look up, but some of the chat is suggesting I basically could have done the same thing, but instead of doing 2 uppercase, I could have done 2 lowercase, but it would have been the same transformation, right? So if we wanted to do this with lowercase letters instead, so a dot char code at, quick break, take a stretch. That's there. Char code at 0. So 97. So we want to take this and subtract 96 from it. Cool. But that breaks on uppercase letters. So what we do is we send things to lowercase now. and then subtract it. So it could work, but just in the reverse direction, and you would say 2 lowercase instead of 2 uppercase, and subtract 96 instead of subtracting 64. But either will absolutely work. JT is mentioning we could use a regular expression to cleanse the punctuation. That might be worth it. So basically, before iterating over the text, strip out anything that's not a letter. Yeah? I think that could work. Cool. Oh, Gaming Bot Not Really is saying, I'm part of a competition programming team for my school this year, so this stream's going to help a lot. Awesome. There are 15 previous episodes where you can see me solve problems in different ways. Cool. Yeah, and I think this is a good first solution, but let me submit this. If this works, then let's do some regular expressions. Let's do like potentially, probably what we could do is a regex and then a map, because the regex would strip out anything that's punctuation, and then you literally just have characters and you're mapping that to numbers. So could be doable. Should be doable. Let's see if this works. Sample tests. Those seem to work. Let's try the bigger tests. And all of those work too. Look at us. Cool. So that's great. Let's do it again, but oh, Alka has a one-liner. I'm not gonna look just yet because I want to try something similar. Cool. Okay. Oh. So what do we want to do? If I want to turn this for loop into a map. Oh. Code Wars apparently was having issues sending the requests. Stop it. Okay. If I want to turn this into a map, I need to get rid of anything that is not a letter. So what JT, I think it was JT, yeah, was suggesting was using a regular expression to cleanse punctuation. So I could do something like, well, let's take an example like this. Actually, let's take this whole sentence. If we were to do like a replace with a regular expression on it and say replace anything, how do you do not in regular expressions? I think it's that. Not, is that begins with, starts with? I'll have to look up the not operator, but anything that's not A to Z or A to Z globally with the empty string. Yeah, not. Not. Let's look up how to do a not with a regular expression. Rejects not. Match string, not containing string. Beginning. End of word. Huh. Which regular expression wrapper means don't match this? You can use negated character classes to exclude certain characters. For example, not. Ah, okay. So it is the hat, but it needs to be in the selector, not outside of it. So I think if I do that, yes. Okay. So replace anything that was not a character with a with nothing, with the empty string, and that gets rid of spaces, punctuation, anything. So this is good. This is what we want. So what we could do, where are we? We are here. Is we could say text dot replace. So get rid of all punctuation, and then split it to turn it into an array, and then map it, which gives us access to each letter, and then for every letter we just do this. Done. And then we need to join it back all together. So then join on a space. So take the text, pull out any punctuation. That now gives us just letters, and we know that we're only dealing with letters. Then turn it into an array, map over that array, and every letter we now want to get its corresponding letter in the alphabet. So that should work, and then join it back together on a space. I think this will do it. Let's try it. Sample tests. At least worked for those. Cool. So now I will look at what Alka suggested to do. Let's see. Let's see. Oh wait, I scrolled too fast. Okay, let's analyze what Alka here has done. This is Alka. Oh, did I press the right? Let me make sure I copied it. Cool. Okay, so this needs to be in the function like this. This will be text. Okay, so take the text. Oh, you know what? I like that. Send it to uppercase initially, and then you don't have to do it inside. Split it into an array, map over it, and now you just have to subtract 64, and then do it a filter. Okay, so it's a very similar solution to mine, but essentially we're kind of doing the filter. This is like filtering out anything we don't care about before we're mapping over it. But in Alka's solution, and I'm sorry, I turned your one-liner into a 5-liner. But his was kind of do the same thing, but then after you have all of the numbers, filter out anything that we don't care about. Very cool. A happy little regex. Oh, and you know what? Alka is a moderator in the Discord, but I forgot to make him one here on YouTube. So there you go. Alka is now a moderator. Yay. Oh, hell, Alka. Spam with emojis. Yay. Yes, and then Alka made the correction. So like I knew this was it was used for not, but if you put it not in a selection of things, it means at the beginning of the word. But if it's in a what are these called? Not a selection, a group. It's a group. I think it's a group. So if you put the not inside the group, it's anything that's not in the group. Cool. Gaming but not really asked, how long does it take to learn all the regular expressions? I think like it varies. I think there are certain things that you kind of like use all the time. So like for me, like A to Z, that matches any lowercase letter. A to capital Z matches any uppercase letter. Those are the kind of things that I have memorized. This is like 0 or more in this group. Yeah, there's some like basic syntax that I memorize. Everything else I have to pretty much look up every time. But there are a lot of really good tools. I don't know if anybody's mentioned them in the chat. I'm a little behind. I got to catch up on some of these earlier messages. Bros and Pranks is asking, greater than 0 and less than 27 have an impact on performance? Probably. Yeah, so like earlier I was doing this check here, or maybe it was what Alka was doing, but yes. So I mean, the simple fact that we're iterating over things we don't need to is going to make it run a little bit longer. That said, this solution actually has more iteration than we can see, because this replace here has to iterate over the whole string to be able to even replace any of the characters. And then when you split it, it technically has to iterate over it to turn it into an array. And then when you map it, it's got to iterate again. And then when you join it, it iterates again. So that's 1, 2, 3, 4 iterations of the string. They're not nested, so it's still just, if we're talking about big O, it's order n. Same thing here. This is just big O of n. But this only has technically 2 iterations, because I have 1 iteration of the for loop, and then one iteration to join it back together. So it would be like 2n would simplify to n. There is a performance impact. In JavaScript, don't usually care as much. Yeah, and they are mentioning, Alka did mention I should do, before the regular expression, just do 2 uppercase, and then the regular expression gets simpler. Okay, I'm going to leave that the way I did it there, but what's simpler would be, okay, make it 2 uppercase first, and then replace anything that's not an uppercase A to Z. Cool. And then we split it, we map it, and we join it, and that should work in the same way. I like that, because then you don't have to 2 uppercase each individual letter. Cool. And then Alka has a one-liner with a regex. Let's see. I'm really behind on the chat. I'm gonna catch up though. We got plenty of time. I'm gonna catch up. Okay. So make it uppercase. This is what I turned my regular expression into. Split it, map it. Hey, we did the same thing. Cool. Great minds think alike. So basically, replace anything that's not an uppercase character, turn it into an array, map it, and then join it. Love it. Yay, emojis in the chat. There's so much chat. Let me catch up. Yeah, I think the Schiffman emotes only work in his chat. Yeah, because I think as a what are they called, member? It was called sponsor, but I don't have access to them here. Okay, we have a breakdown of regular expressions. So parentheses and squares in regular expressions are groups. So anything in here, those are called groups. Oh, wait. Never mind, I was wrong. So parentheses are groups. Square brackets are character sets. This is not matching groups. Oh, I see. So this is how you negate inside of a matching group, and then this is how you negate inside of a character set. Interesting. Clarification is non-matching. Yeah, and Alchem is mentioning, so we're talking about regular expressions. At one point, I definitely thought I could never learn regex, and now I'm way comfortable. I don't feel comfortable with regex. I feel comfortable with figuring out what the regex should be, but by no means am I able to just like, what's the word? Just make it appear, just like write it all out. It takes some thought for me to be able to do it. Yeah. And Christian's mentioning, look it up every time I happen to need it, basically starting over every time. I think it gets a little bit easier because you remember like the basic parts about it, like character sets, not something at the beginning of the string, the end of the string, you know, I don't know. Oh, I made it to the bottom of the chat. Cool. Skelly is asking, is there a performance difference between if I flag and have upper and lower in a group? I have no idea. And I think that would depend on the regular expression engine that you're specifically working in. My thought is maybe not, because ideally this regular expression would only run through the string once, and every character in the string it potentially would try to match against this and then say it's not. I mean, I'm assuming and hoping that maybe they implement it that way. So if you think about, like, if we had to implement this ourselves with JavaScript and we didn't have regular expressions, this is my break timer, by the way, maybe we would create an object with the keys of like A through Z, and capital A through Z with a value of true. And then for every letter, we see if it's in the object, which is like an instantaneous operation. So maybe not. I don't know. I think it depends on the regular expression engine. Cool. JT is asking, are you still using your chat monitoring app? No, and the only reason is because right now the the ID of the live video is hard-coded, and so every time I'd want to use it, I'd have to redeploy. Soon, I think I'm just going to do a chill stream where I make that thing work with login, where like I can log in, I can list my streams, I can click on a stream to see the live chat for that specific stream. Because right now it's hard-coded. Right now I'm just scrolling through the YouTube live chat. Yeah, and Randy's mentioning, wait until you get 500 plus people in the room like Schiffman does in the coding train. Yeah, right now it's doable. I think I have, right now I have roughly 30 people, or like it jumped to about 40 or so earlier. It's nice. I can talk, I can interact with the chat, but it's going to be tricky when there are a lot of people. Wow. Gaming but not really asks, are there pre-made array sorting methods in JavaScript? You can't call them out by name. You can just say array.sort. And it depends on the JavaScript implementation as to what it does, or which implementation it uses. Is it quicksort? Is it merge sort? Is it something else? But typically you can just do array.sort. It does take in a comparator function. So for each element in the array, if A is greater than B, then return -1. If A is if A is greater than B, return 1, meaning it comes after it. If A is less than B, return -1, meaning it comes before it. And if they're equal to each other, you return 0, meaning they should appear in the exact same place in the sorting order. This is the function that you give it, but there's no way to tell it which sorting algorithm to use. But it technically can sort an array. Oh, okay. I misunderstood what Alka was saying earlier about regular expressions. This one, parentheses, question mark, colon, means that the match will be dropped from the output. Oh, interesting. So it's kind of like a replace built into a regular expression? It's not a not like the not that we're using in the character set. Very interesting. Okay, I've talked about this long enough. There's probably one thing I want to show is instead of splitting the array, we actually should be able to use the array prototype map, maybe. Let's see. This is what I'm thinking. So send it to uppercase, and then replace anything, and then split it, map it. But instead of splitting it, we should be able to say array.prototype.map.call. So we're going to call the map function using the result of this expression, which is a string, and passing it this function. So this should actually work, but it reduces, like we were doing one less iteration now. So instead of calling the split function, this will just literally call map on an array because it's iterable. Let's see if this works. Nice. And that's one less iteration. So I like that. Yeah, I like that. Okay, I think I'm going to submit this one. Gaming, but not really. The editor I'm using is VS Code. And actually, a lot of people were asking on the live stream last night about what are my settings. I totally forgot. I pointed you to or anybody that was asking, to a YouTube video, but I also have a GitHub repo, and I forked it to the Coding Garden organization last night. There's this repo called VS Code-settings, And I have in here what font am I using, what is my theme, what is my icon theme for all the icons that show up here. There's that bracket pair colorizer, that's really nifty, and all the other extensions I use, and all of my settings for VS Code. So you can check that out. Let me throw it in the chat. Visual Studio Code is what it's called, yeah. Visual Studio Code is specifically a text editor. So Visual Studio is like a full-fledged IDE. Visual Studio Code is very similar to Atom in that it's Electron-based and it's more of a text editor with plugins, extensions. Yep. Okay, I'm going to submit this one. Attempt. Sweet. Final submission. This is taking a while. We did it. Yay. Cool. Actually, so this is one way I wanted to solve it, but I didn't. But basically, instead of using like map and stuff like that, we could have taken our first solution and so in our first solution, we did this and then we joined it all together at the end. But we technically could have, instead of pushing it into an array, we could have just appended it with space on the end every time. So let's just show that really quick because it's this is probably the best solution in that it's only one iteration. If you go from the beginning to the end and then you have the answer. So let's do this. Instead of being an array, let's make it a string. And I'll say numbers plus equal number and a space after the number. And the only issue now is that we only want to put the space at the end if it is not the last one. So like technically this would work. Let me run this one. I'll move it down to the bottom so it'll run. Okay, so this works, but the one issue is, I don't know if we can see it. The one issue is there's a space at the end, at the beginning. Yeah. But I guess the way they fix that is by just removing the space right before returning. We could, okay, we're gonna do this all in one iteration. If we say, okay, plus, and we'll say if I is not equal to text.length minus 1, meaning, oh, we don't, yeah, so if we're, okay, so if I is not equal to text.length minus 1, then we're going to append a space, otherwise we will append nothing, and that should get rid of the space at the end. I guess the only issue here is what if you have a string that has like spaces like this, then it's technically going to put a space here. Oh, you know what? I can just trim it. I can just trim it. I'm just going to trim it. That's probably the easiest way to do it. Numbers.trim. Cool. Cool. I like this one. Actually, I'm gonna try it again and submit this one. Sample test. No! Assignment to constant variable. Oh, of course. This needs to be a let. Oh, let. There we go. And attempt it. Boom. Cool. Yes. You all in the chat are great. Yeah, Evan is asking, and hello, Evan. What is the difference between VS Code and something like Notepad Plus Plus? Probably the plugin and extension marketplace community. Like, I know Notepad Plus Plus does have plugins, but and I used to use it a lot when I was on Windows or working the majority of time in Windows. But VS Code also has things like in what they call Intellisense. So like if I do like text dot, I don't know, split, typically if it can infer like what is the type of the thing. So actually it now knows that numbers is a string. So if I do dot split, it infers that numbers is a string, and it gives me all the documentation on like the split function. So like VS Code has this built in, like it can detect what your code is and give you suggestions, and smart suggestions, not just suggestions based on the text around it. I don't know if something like Notepad++ can do things like that. Yeah, and I saw it was really cool to see. The stream that Dan on Coding Train did, where he was showing his setup. He showed he was using Visual Studio's code. I didn't get to watch that whole stream. I kind of like listened in every now and then, but it's very cool to see. I made the switch like at the beginning of this year. I was using Atom for probably like 2-3 years, and if you go back to some of the earliest Coding Garden videos, I was still using Atom, and then eventually I switched over to VS Code. I love it. It's really good. Yeah. And JT suggested just trim it. I definitely trimmed it. Cool. Yeah, and the reason I like this one versus something like this is just because it's one single iteration. Even doing something like 2 uppercase, like 2 uppercase, if you called it on the whole string, would have to iterate the whole thing. This specifically just has to call it on one letter. I don't know. There's the implications of like having to check this. I don't know. It's cool. It's cool. Okay. I've been streaming, I guess, about an hour. Yeah, I probably have time for one more. Maybe. let's see. Maybe I'll pick a very doable 5Q. Valid parentheses. This one always scares me. Like, have I done it before? Let me see. No, I don't think I have. Write a function. Write a function called what? Okay, that takes a string of parentheses and determines if the order of the parentheses is valid. The function should return true if the string is valid and false if it's invalid. I'm going to hold on to this one. I think I've purposefully not tried to solve this one on stream. I'm just kind of scared of it. I could probably do it. I just don't want to take like an hour to do it. Product of consecutive Fibonacci numbers. Whoa. Cool. Yeah, gaming but not really has a suggestion. Create a stack. I guess that could be cool. Yeah, so like if you get an open parenthesis, you push into the stack. Anytime you get a closed parenthesis, you pop off of the stack. And if your stack is empty, it's legit. But if maybe you can only, yeah, I think so. Yeah, I mean, that sounds doable. Are y'all going to coerce me into doing this one? Because I've been avoiding it for so long. JT is saying, a classic intro problem for a recursive function is the parentheses problem. Interesting. So I guess technically I'm not the best at recursive functions. I don't even know how I'd start to think about that recursively. Quick stretch. Gaming but not really says do it. Let's look at this product of consecutive Fibonacci numbers. The Fibonacci numbers are the numbers in the following integer sequence. So each number is the sum of the previous two numbers. 2, 3, 5. Cool. Okay. Given a number, say prod for product, we search two Fibonacci numbers n and n+1, verifying that the two multiplied by each other is equal to the product. Okay. Your function product fib takes an integer, which is the product, and returns an array. The two numbers that multiply to equal it, or one. I don't like how they worded this thing. Let's look at something else. I might do the parentheses problem. Elaborate is mentioning have the open parenthesis equal 1 and the closing parenthesis equal -1. The total should equal 0. But this is why I'm scared of it. Because no. But, well, not because no. We could probably think about it that way. But, okay, I'm just going to do it. I'm just going to do it. I forgot to link to... Which one did I just do for the 6Q? Replace with alphabet position. Oh. I just want to put this URL in the README. Okay, we're going to do it. We're going to do this parentheses problem. If it's the last thing we do, it may be the last thing we do. I don't know. Okay. It will be the last thing we do. Let's do it. Valid parentheses. Okay. But yes, and Alka has an example of where the 1 and the -1 wouldn't exactly work. So, I mean, if you just take the simple case of like this is not valid, but if you accounted for -1 and then +1, this would equal 0, but it's not valid. So you need to keep track of, is there an opening and a closing? Not just like does it start with an opening and then end with a closing? Not is it just two matching pairs? Okay. Oh, and JT is saying, and you have to check if your sum is never negative to handle the this case. So let's say, so if we say this is -1 and this is 1, the current sum would be -1, and we would just stop there because the current sum starts off as -1. Oh my goodness, is it that easy? That might be really easy. Hello, Himanshu. Good morning to you as well. It's evening for me. Alka is saying the string must be even length and it cannot start with closing parenthesis or end with opening parenthesis. I just think it's so much more trickier than that. Let's do it though. Okay, click the train button. Oh, train, coding train, cool. All right, this is our function. These are our examples. And let's start up Clocka. I'm losing it. I'm spacing. This might not be a good idea. Yeah, so in JT's version, if we add it left to right, it should always be a positive sum. It should never be a negative sum. And if it is, you got it. Okay. Let's go with this. Let's try to do the summation thing. So initially suggested by Elaborate, where open parenthesis is worth 1 point and a closing parenthesis is worth a -1 point. Okay, and you're going to sum up the whole thing. And if equal to zero, valid. And also, I got a donation. Was it a super chat? Was it a donation? It was a super chat from Himanshu. Thank you so much. I actually don't know what currency this is in. Can I look at it? But thank you. You're fantastic. Thank you. I actually do want to see what currency is this. The Indian rupee. Awesome. Thank you so much. And I guess, did you have a message associated with your donation? Let me see. No message, but I really appreciate the donation. Okay. So sum up the whole thing. If equal to 0, valid. And we'll say if the sum is ever negative, not valid. This could work. In theory, it could be this simple. Okay, so a comment from Himanshu. Thank you for making this channel. By far, this is the most helpful channel that I've found. You're very welcome. Happy to do it. Okay, so I think we have a place to store the sum, right? And initially, the sum is 0. And now we need to like iterate over the parens. So like sum up the whole thing. This should be like iterate over parens. Let's do some proper pseudocoding. I'm getting ahead of myself. Okay, so a place to store the sum. Great. And this will be initialized to 0. And then we will iterate over the parens. And if a open paren, add 1 to the sum. If a closing paren, subtract -1, we'll subtract 1 from the sum. If the sum is negative, return false. If we make it out of here, and if the sum is equal to 0, return true. Else false. In theory, this could work. Let's try it. It could break for like larger sets of parentheses, but I mean, I think this sounds good. I never thought about it this way, but let's do it. Let's do it. Okay. Place to store the sum. We'll initialize it to 0. Awesome. Iterate over the parentheses. So let's just do a for loop. We'll say go over the parens length, and the paren singular is going to be parens bracket I. Okay. If this is an open parenthesis, so if I thought of a way to like write this shorter. I'm gonna do it with an if statement first. So if paren is equal to open, then we're going to add 1 to the sum. So we'll say sum plus equals 1. And if it's not opening, it must be closing. So we could do a check, but either way, we'll just go ahead and subtract 1 from it. So if it was open, we add 1. If it was closed, we subtract 1. If the sum is negative, return false. So if sum is less than 0, return false. Otherwise, keep going. And then when we get out of here, we want that sum to be 0. Because if it's greater than 0, it means we have too many open parentheses. So if the sum is equal to 0, return true. So if sum, actually, I think we can just return, we can do this all in one go. So return sum is equal to 0, because if it's not, then it's false. So this works for our very simple cases. Let's try it on Code Wars and see what we get. So sample tests, It's okay. Let's try it with bigger sets of parentheses. Oh my goodness, that was too easy. Okay, I mean, obviously through wonderful suggestions in the chat, we did it, but I really have been avoiding that one for a long time because I thought I couldn't think of how to solve it. Can't believe that worked. Okay, let's clean it up though. So that's our initial solution. Server error. Okay, let's get rid of all our comments. Let's make it nice and short. Okay. Yeah, and it would be interesting to do it recursively. I don't know if I can do it tonight. I'm getting pretty drained. Maybe we can think about it. Because I don't even know, like, what would the base case be? What are you recursively calling it? Oh. You're recursively calling it by removing parentheses. But what if it's like 2 sets of parentheses? I don't know. Regardless. So one thing I want to do instead of this if else, we can create something like, call it like values. And that's an object where open parenthesis is 1. Oh, no, you know what? Yeah, we'll do this. Open parenthesis is 1 and closing parenthesis is -1. And then instead of this if else, we can just say sum plus equals values at that paren. That should still work. Cool. And then we could probably turn this into a reduce. Not quite, because we kind of like need to return out of the reduce. Yeah. JT is saying, oh, in terms of the recursive solution, I think I cheated and added a sum as a parameter to the function while trimming the string left. Could be like an optional parameter. Interesting. Yep, gaming but not really is saying, I noticed you use triple equals. Lately, mainly because me I am so me said something about it. I actually like a lot of like technically in this case double equals will work because both of these are numbers and that, I mean, yes. But yeah, yes I'm using it. Basically this compares type and value, not just the value, and double equals will do coercion only if the 2 types are not the same. These 2 things are both numbers, so coercion is not going to be happening. But regardless. Okay, so this is cool. This like makes it a lot smaller to do the value checking. Let's see. Yeah. It still works. It still works with the larger case. Can we make it smaller though? Oh, okay. I've got a tricky solution here. Okay, so here's what we're gonna do. So notice this is a for loop that essentially is going to, like, anytime we add to it and we don't need to return false, it just returns true. But if it ever returns false, then we know that this thing doesn't work. So here's what I think I'll do. I'll do a sum. Any? Let me see. Array sum. This tests whether at least one element in the array passes the test implemented by the provided function. So I think we want something like, we want like every. So we want to make sure that everything doesn't return, like everything potentially would return true. So I think we can use every and turn this into an every, and if it returns false, then the whole thing returns false. But if not, we check the sum. I think it might do that. Cool. Gaming but not really says, gotta go. It's been a blast to talk. I'll see you later. Have a good night or morning, wherever you are. Evening, afternoon. Cool. Okay, so let's turn this into an every. Quick stretch. Whew. Okay, so I think right now we'll leave the sum variable. And in order to use every, we would need to split it because it's an array method, but we can use it on the prototype. So if we do array.prototype.every and call that on parens, and then pass it a function which will give us each paren, basically we're going to do this inside of the every. And like otherwise we return true. And this is going to create a variable called like is positive sum. Cool. And we want to return is positive sum. Wait. We want to return if it's not a positive sum. Yeah, so if any one of these returns false, then every will be false. Or, I think this is what we want. So, if everything returns true, no, we need to do both. We actually need to do both because if everything returns true, we still need to check to see if the sum is equal to 0. Let's go back to the for loop. I'm telling you, I'm getting foggy. I'm way too exhausted today. Okay, this is where we were before. If at any time the sum was less than 0, we returned false. So really I should do, I probably want a variable that's like is negative sum. And that's going to be if everything doesn't return true. And that's where I'll do the every call. So call it on parens, get access to each paren. And then do this. I think that's it. So if everything returns true, then that means it's a positive sum. But if we not it, then that means, does it? Oh, I can't think straight. Sum is the inverse of every. Let's think back to what sum does, because I initially ruled that one out. Test whether at least one element in the array passes the test. I don't want this because this would finish the moment it got a true. I want it to jump out if it ever returns false. Yeah, so I think not it. So if it's a negative sum, then we return it. Wait. No. Is positive sum. Is positive sum and sum is equal to 0. What's happened? Oh, are there some like stray parentheses here? Oh, dot call, sorry. So if it's a positive sum and that sum is equal to 0. I think that'll work. Let's see. Sample test. Okay, bigger attempt. Okay, I'm telling you, my brain is way too foggy. Hey Amy, welcome to the stream. Okay, that did it. Can I potentially turn this into a reduce of sorts? Yeah, I mean, the reason I like every is because the moment it turns false, every stops. So that's how like every and some are different from like map, filter, and reduce. Map, filter, and reduce are always going to go over the whole array. Every and some will stop early if, in terms of every, if anything returns false, but in some, if anything returns true. So that's why I like every. I don't want to turn this into a reduce just yet. But we could kind of turn this into a one-liner. Like one trick, I actually saw me do this as a default parameter. Now you can get rid of the variable. So if I put that there, now I don't have a variable inside my function. It's still technically like it's a parameter. It's an argument to the function. And then, well, here, I'm going to do this on a separate one. Okay, so I've got that. That one works. And don't get me wrong, there are probably other ways to do this. And someone suggested earlier using a stack. That's probably a valid way to do it too. But as you may have noticed, my brain is getting very foggy. I need to get home, so I'm not gonna try another way to do it. But it would potentially be doable. Okay, so now we have our initial value there. That's great. And then instead of using values, I could just like put this there. Cool. And then really we can just return this whole thing. So return this and sum is equal to 0. Look at that. Look at that. And then we can turn this into a one-line return statement. So return sum less than 0. Not less than 0. No way. Does this work? Wow. I surprised myself. Okay. That's cool. I like that. I can't believe that works. I can't believe it was so much easier than I thought it would be. Like, I'm telling you, I've been avoiding clicking on that one for a very long time. Okay. I have only been streaming for an hour and a half. Typically, I stream, this stream usually lasts like maybe 2 hours, 2.5 hours, but I'm very busy. I'm very tired. I'm glad I got to stream tonight. I'm glad I got to talk to all the wonderful people in the chat, but I am going to call it there. As I mentioned, all of the code that I wrote tonight, I will push up to this GitHub repo called Code Katas on the Coding Garden organization. But that was really fun. Let me make sure that I link to this one that I just... here I am saying that I have to click Submit Final to know that it really works. Let me copy the URL. Is it really going to work? I don't know. JT says you did it. I did it. I did it. It's submitting. I think it's gonna work. Let's say it works. Cool. I think they kind of did it in the same way. Have a tokenizer executing on the string. Interesting. Interesting. I like my solution. I really like it. It turned out pretty cool. So we're doing an every. We got this cool little object that's giving us the values that we're going to sum up. And yeah, very cool. Oh, that's much more readable, Alka. I like that. So return sum greater than or equal to 0. Yeah. Instead of like not sum less than 0. What's that about? Cool. Yeah, I'll leave it like that. I like that. Oh yeah, let's see if there are any recursive solutions. No, this one's using a stack. It actually looks pretty easy. So you have a stack. If it's a less than, you push into the stack. And if it's not, then you need to make sure that the thing you pop off is not an opening parenthesis? Really? Is it that easy? Interesting. No recursive solutions yet. I don't know, did I... let me know if I bypass one. We're looking for a function that calls itself. No? No? No way. So this person, I think, like hacked the system. So they figured out what tests were being passed to it and just returned an array with those tests. Like, there's no way that, like, this does not check valid parentheses. I've never scrolled this far down in the list, but this is probably like earlier before they added like random tests. And someone can literally just say, okay, I know that each of these should return true or false, so I'm just going to return true or false depending on what run it's getting called in. That's hilarious. This one might be a little recursive. It's very redundant. I don't know. There is another suggestion from Alka. Let's do it. Let's make this even smaller. Sum plus equal. Oh, because that's going to return the sum. Wait, or is it? Oh. That doesn't seem to work. So you are suggesting. Oh, I need to return it. That's why. Never mind. Whoa, that's some tricky business right there. Oh, and hey, Alicia, happy birthday, Alicia. Missed the entire stream. No worries. It's a shorter one tonight. You can probably watch again. We just picked them from scratch today. But have an emoji, a happy birthday emoji. Party? This one. Enhance. Happy birthday. Cool. Don't say that. No. Okay. Yeah, this I mean, if you just looked at this looks like utter nonsense. But it's cool that it works, and I'm glad that it works. I am gonna call it a night. You're right. I need to leave. That was fun. The last thing was I wanted to see, and JT was mentioning, I wanted to mention or see if there were any recursive solution. Okay, here's one. They're putting a recursive function inside of valid parentheses. Interesting. Oh, and it's because their recursive function takes in an array. Okay. If the open parenthesis is not found and a closing parenthesis is not found, then it's valid. If a opening parenthesis is not found or a closing parenthesis is not found, it's not valid. If the first, an index of always returns the first index. So if the first index of an opening parenthesis is actually greater than, that means they're swapped, a closing parenthesis, then it is not valid. Interesting. So these are our base cases for the recursive function. Open will be finding the first open parenthesis. And then we're looping. I feel like this is doing more than a recursive function should actually do. Yeah. Okay, I'm gonna call it a night. Maybe next time, or not next time, maybe one day in the near future, we'll do it with a recursive function. Okay. Like I said, all this code will be pushed up to GitHub. Thanks so much for everyone for tuning in, for interacting in the chat. It's been a fun time. Next stream will most likely be either on Saturday or Sunday. I've got a busy week. Tomorrow, moving out of my apartment. Friday, flying back to Denver. But then I'm just gonna chill. It's gonna probably be like a chill stream on Saturday or Sunday. Cool. One last chat from El Borate. I love the Code Wars video theme. I'm glad the Coding Train collab happened. Wish you the best and look forward to the next one. How often do you do the live stream? Thank you very much. First, so typically I do Code Katas. I've made it a tradition now every Wednesday. Actually, let me show it on YouTube. I'm pretty proud of how many Code Katas streams I've done so far. Let's look at playlists. Yeah, so look at that. This is number 16. And I've missed a few Wednesdays here and there, but for the most part, I do this stream pretty much every Wednesday. All right, see you, Himanshu. Thanks so much for the donation. I'll throw that back up again because I really appreciate it. There's that. Maybe? I think it'll pop up, but thank you so much for the donation. Alan says, thank you. So glad I found your channel. You're very welcome. See ya. Have a good one. Okay. I think that the thing is that thing's going to pop up in any second, but regardless, wherever you are in the world, have a wonderful morning, afternoon, evening, or night. Thanks so much for tuning in, and we'll see you next time. Here's this.